Hello guys, I know I promised to make a video on like rockets and space, but I'm gonna be going over a topic many people struggle on. Well, not many people struggle on it, but people oversee the subject as to be really hard to do, which is called this special thing. Let me show you guys. Integral. Let me put an image for you. Integral math, which many people see this as as a scary, topic, which is this right here. An integral. This is an indefinite integral. If you guys don't know what an indefinite integral, I'll try my best to explain this to you guys. Um, so basically, an indefinite integral is a integral which has no upper or lower limit, which a lower limit is this. Or let me show you a definite integral. Which a definite integral has a number at the bottom, which let's just say it's 0 and 2. Which this is a these are the coordinates of where you're trying to estimate something under a graph. Well, for example, if you're estimating this graph right here on the x and y plane, sorry for the poor. Let me just erase the integral. If you're trying to find the 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 sum or like the sum of this area under this graph, we have to do the integration, which we have a coordinate here and a coordinate here. So, for example, this coordinate 0 and this coordinate 4. Our coordinates would be 0 and 4, which then we could apply this integral into this 0 and 4, and obviously they're going to state a function for this. And for example, if we just use a function of a parabola, we're just only using this side of the parabola because it states what side of the parabola you may use or what coordinates you may use. So if we're just using the right side of the parabola, like positive numbers, we'll just use that. For example, I'm just going to make a random equation, which is x squared. Which, if we use x squared for this equation, we first have to derive this integral right here. Or not derive, what do I mean? Evaluate this integral. Sorry for writing one thing. I just messed up. I got confused. Which I haven't shown you guys how to do it yet. So that's the first thing I'm going to be going over. Let me make this eraser a little larger. Because it's not eraser. Okay. We're going to go over the indefinite integral. Today we're just going to go over some simple ones. And then another day I'm gonna go over like maybe some trig functions. Trig functions should not be that hard. Trig functions are the worst. You just have to know your unit circle if you're doing a definite integral, and if you know an indefinite integral, you just need to know your derivatives of simple trig functions like sine and cosine. But today we're just gonna go over simple equations or functions. For example, let's evaluate this right here, x squared of dx. I'm sorry, I don't have touchscreen on this computer, so I'm doing it by keyboard. So basically, if you guys are trying to figure out what this right here is the I don't know why I did that bad, but don't mind my writing, guys. But this right here is just the power rule of integrations, or technically, I don't know how to explain it fully. I will try my best to explain it in the next video, but this is what it is. I'm doing it in my writing. It's kind of bad. Which a is just any variable, which I'm just stating as an a. So right here, if you guys know how to do derivatives, which I haven't shown on this channel, but I am assuming you guys are trying to get help for integration, so I will try my best to show you this. If you know the derivative, or if you do the derivative power rule, which is this, let me show you, which is this, a n minus 1, which then you do that, but you have to multiply the n over here, which is n. For example, I'll give you guys an answer. It's not subscript n or anything, it's just I wrote it forward. I'll give you an example of a derivative. A derivative that we could probably do is x squared, which we're doing over here. I'm sorry about that. We minus the 1, or we first bring this to a front. So once we minus the 1, I don't know why my writing's so bad. My fingers are guys, I'm sorry. I don't know why my writing's so bad, but the first thing we do is to we once we minus the one, our x will just be x, which is 2x, or just if you want to write it as one, we can. But the one doesn't really, you don't really need to state the one. So the one right here is just means that we minus the one, so that will give us this answer. Don't mind my poor circling, but once we have that, we do the integration of this. We don't multiply the front. We actually divide this into whatever number we get up here. So this would be a, or not a, n plus 1. N plus 1, which it states here. A to the power of n plus 1 divided by n plus 1. Which this, you might get a little confused on this part, but it just means this, basically. Just erase that. So now let's apply that rule to this. If we apply this rule, we have x squared plus 1. So just remember, whatever we get up here, that's whatever we divide by. So obviously this will be x to the power 3 divided by whatever we get up here, which is just 3. Don't forget the constant, which I'll explain to you guys right now what the constant means. Well, basically what the constant means is what any constant, it's just any constant. Basically when you do derivative, for example, if you do the derivative of 2, it turns into 0, which we don't state that. That is a constant. So if we have x squared plus 2, our derivative would be 2x plus just 2x, because the 0 isn't, the number is gone basically. You don't have to include a 0. So the 0 is just disappears. So basically for integration, we have to state that there's a constant there, because what if this, for example, this derivative right here might have had a number over here before, but right now it's just this, plus 0, x squared plus 0. I mean to delete everything, but export, if you guys could hopefully hold on with me. But yeah, that would be that. So this just states that there is a constant there. We don't know what number was there, but there was a constant there eventually. So basically, this is what the constant means. The constant, I don't know how to make the sign. It's like something like this. It states that the constant is a real number, or should be a real number. So that's that. Give me a second. So we've done that derivative, not the hardest derivative to do. So I'm gonna give you guys a practice problem. Just write it down for you guys. Give you guys a variable. Try and do this at your best ability. You can simplify the fraction. That's all I'm gonna tell you. Go ahead, pause the video and do it. I'll give it. Let's solve this together to see if you got this right. So basically, we have to apply our power rule. Add this by 1. I'm just gonna put it up here so I don't waste so much space. And then divide it whatever. So we have 6 6x to the 4th divided by 4. So we can simplify this by 2. Oh my god. I'm sorry guys. I'm doing really bad with this. My finger hurts. 3x to the 4th. Don't forget your constant. Your constant would be, let's see. This is 4. Let me just take this 4. Forget your constant, you'd probably get it wrong. This is really important for later on, like maybe applications of derivatives, what you will need to know these rules. If you because integrals do have various rules you have to apply, which later on you will need to know these simple rules. If you don't know these simple rules, you're gonna be you're not gonna have the funnest time doing integrals. So I recommend trying to memorize these rules. The next thing we're gonna go into is exponentials, which I don't like doing exponentials myself because there's something called use substitution, which I'm not gonna go into that much during this video. This is integral, or what's the integral of e of x or d of x, which our derivative, if you guys know, it's like I love this derivative because it's so d of x or e of x. The derivative of e of x is just you guys know the simple derivative is just e of x, which it's like I see names on TikTok where it just says the most nonchalant derivatives, which the most nonchalant derivative is e to the x because it's like the easiest derivative you could do. So basically, this is basically this exact same thing that with integration, which is the integration of e to the x. It's just e to the x. But you have to add a little something. Let's just add a wild. Guess what that is? It's that is the simplest integral. That's that's the as most people say it's the most nonchalant integral, which we could actually apply right now, but we're not gonna apply it. I'm gonna break into a little bit a bigger equation. If you guys get what I mean. Let me go ahead and pull equation from the practice sheet that I found. So here it is. Let me just on full screen. We have 10x. This one's actually pretty simple. 10x 9 minus 12x to the minus 5x. I'll give you guys some time to do this. I'll show you. Oh no, it's not 5x. Wait up. It is just 5. I don't know if it's plus or minus. Give me a second. It is minus. Okay. Go ahead and try and solve it. I forgot the d of x. Don't forget the d of x. Nice. D of x. Go ahead and try and solve this. And I will go over it. This can be a last problem because I'm just going into a simple introduction. This can be our first video about this. Just a little small introduction about this, and that's it. Now let's go into it. Or I forgot to say, but pause it. Or if you didn't, just pause the video and try and solve this on a separate piece of paper and see if you get it right. We're starting with the simple things first because once we get to the hard things, it's not going to be fun. And trust me, I know this. I've done some of them. We haven't learned it in my class yet, but I've just gone ahead and I want to try and teach other people how to do it if I can. So this is a little test to see if I can do this. So basically, if you see we did the power rule, this just goes away. And then we have over here, this is going to be 12x to the fourth divided by 4, which we can simplify. We can simplify by 4, so negative 12 divided by 4 is just 3. Now over here, right, easy one, 5 to x. If you guys don't understand how that got it, I'll explain right now. So basically, if you don't know how to do this one, we will get, so basically think of 5x, or just 5 to, of x, or just think of 5 to, no, I'm tweaking, I'm sorry, but think of 5 as this, 5x 0, so anything to the power of 0 is equals 1. If we apply the power rule, we just add 1, which we just have 5x to the power 1, which is just 5x. Divide whatever's here by 1, which is 5x divided by 1 is just 5x. So that's how you get this. It's not that hard. It's pretty simple. Let's just clean this up a bit. X to the 10th minus Next video, I will be going over simple determinate functions, or determinate, oh, what do I put over some simple determinate integrals. It shouldn't be that hard. Well, I'll explain to you guys further what that means, but you won't. Just remember this for the next video. I'm using Canvas for this one. Not really better trouble. Oh yeah, don't forget your constant, or you would be. So if you didn't simplify, I would say you might get it right. If not, you're not getting it right. So I recommend to simplify it as much as you can. But I think you can leave this one as 12 to the 4. But this one is pretty easy to simplify, so go ahead. And always be careful, because like on my test, I keep forgetting my pluses or minuses, or my negatives and additions. I don't know why, I just go really fast, so I recommend you guys to go over what you're learning before. But thank you guys for watching my video, and I will go over indeterminate fun or indeterminate integrals next. If you guys want me to like do a certain subject, I will. Just tell me. Okay, guys. See you guys in the next video.